Hi guys, welcome back to my YouTube channel, and in today's video I'm going to be teaching you how to take the derivative of trigonometric functions. Okay guys, so we're going to start off with these two examples first, and I've already shown you guys how to take the derivative using power rule, and it can be applied to the derivatives of trigonometric functions as well. So here, for a, it's y equals sine 3x. So what you want to do is treat the trigonometric function and the theta value, the angle value, as separate. So you want to take the derivative of both of them separately. First, you take the derivative of the inside, which is 3x. When you take the derivative of 3x, you use power rule and you're only left with 3. And when you take the derivative of the second, the trigonometric function, you're going to take it all together. When you take it all together, all you're going to take the derivative of is the sine. You're going to keep the 3x the same, and you're going to take the derivative of sine. And there are some rules. I'll actually put a formula sheet on the screen, like right now. And in that, you can see the derivative of some trigonometric functions. Like for sine, the derivative of sine is cos. So the derivative of this function would be y equals 3 cos 3x. So I'll write it down. Okay, guys, so here I wrote down everything I just explained. Basically, you have to take the derivative of the angle, right? So just put the prime there. I put it there so you guys know that the next step of this is just 3. I took the derivative and I got a simple 3. And the sine 3x just goes to cos 3x because the derivative of sine is cos. Your final answer is 3 cos 3x. So let's do it again on B. B, it's just the same exact thing. You're going to take the derivative of the inside and then take the derivative of the whole thing. So when you take the derivative of just x plus 2, using power rule, you know that constants turn to 0. Okay? The constant is 0. And when you take the derivative of just one variable, you're going to get 1. Because using power rule, you'll bring the power of 1 down, and the power 1 minus 1 equals 0. So you'll get 1, simple 1. And you know the derivative of sine is cos. So it's just going to be cos x plus 2. I'll write it down. Okay, guys, so here I wrote down everything I just explained. The derivative of x plus 2 is just 1, okay? And then we took the derivative of sine x plus 2, which is cos x plus 2. Our final derivative is just cos x plus 2. So let's move on to another example. Okay, guys, so this is the third example. And here, it's a little bit different, but it is pretty much the same thing. It might look intimidating, but it's just simple power rule. I drew the lines so it's easier for you guys to understand where you're taking the derivative of. You'll take it as a whole first, and then the inside, okay? So, as you know already, the derivative of sine is cos, so the first part of it will be cos x to the power of 3. That's the first part of the derivative. And then the second part will be the inside, which is x cubed. For this, you'll use simple power rule. And the derivative of x cubed is just 3x squared. Okay? So I'll write it out so you guys can understand it. Okay, guys. So here I wrote everything I just explained. Cos x cubed, and then the derivative which we're going to take. And when we take the derivative of this with power rule, we get 3x squared. So the final derivative of this function is 3x squared cos x to the power of 3. Let's move on to one more example. Okay, guys, so this is the last example we'll do for today. This is y equals sine cubed x. So whenever you see something like this where the trig function is raised to a power, you can automatically just assume that the whole thing is raised to that power. These two are basically, they just mean the same thing. So looking at this is much easier because taking the derivative, you were going to use two things. You're first going to take the power rule of the whole thing, and then you're going to use chain rule. So this question also has two parts. You'll take the power down using power rule, and then you'll take the derivative of the inside, which is chain rule. So I'll write it down so it's easier to understand. Okay, guys, so here I just wrote it out, and I'll explain it one more time. Here is exactly what I said before, power rule. We put the whole power rule on this, and the inside is going to stay the same because the power rule just depends on the power. And then for the inside, we'll use chain rule next. So we use power rule, decrease the power by 1, put the coefficient down, okay? That's the first part. The second part is chain rule, which is taking the derivative of what's inside the power. So it is sine x. Now the derivative of sine x is cos x. So our final derivative is 3 sine squared x cos x. And there is a nicer way to write this by just putting the power on the sign. I'll write it out. Okay, guys, here is just a simpler way to write this by putting the power on top of the trigonometric function. It's the same as this. And yeah, these two mean the same thing, but it just looks nicer like this. So yeah, and this, to summarize, we use power rule and chain rule. Okay guys, so that's all for today's video. I hope taking the derivative of trigonometric functions wasn't that hard. When I first started doing it, it was, I think, the hardest part of Math 31, but with practice, it becomes really easy. So just make sure you're practicing, like, even 5 minutes a day will help you get far. So yeah, that's all for today. See you guys next time. Guys, this is my brother and he wants to say hi to the video. Just say hi.
Hello, my name is Musa, and I love to play basketball, cricket, and football.